Awesome. I'm Feross from WebTorrent. Oh, thanks. Thank you. So I'm honored to be here. The point of this talk isn't to share technical details about WebTorrent or status updates or to discuss new technology, which is a little out of character for me, I guess. But I think it's valuable to once in a while reflect back on what we did right and wrong. And so that's what this talk is about. So I hope that in looking back, you can take some lessons from what has worked for WebTorrent and apply it to your own project. And I think we've made a lot of mistakes, both like technical mistakes and organizational mistakes. And we've done some things right as well. And hopefully you can glean something useful from some of my thoughts. So first, some background so we're all on the same page. I started WebTorrent in 2013. I first shared the idea on stage at Real-Time Conf in Portland. It was one of the, actually it's not really Portland, but yeah, one of the first conferences that I ever spoke at. And I was talking about WebRTC. I was really excited about WebRTC and how we used it at my startup, PureCDN. So I mentioned the idea for WebTorrent as an afterthought. I basically threw in a slide at the very end, and I was like, here's an idea. So PureCDN was trying to be this content delivery network, the world's largest content delivery network without running any servers. It served a website's static resources using WebRTC, so things like images and videos. And if we were starting it today, we'd probably call it the Uber for CDNs or something like that. Yeah, so my co-founder and I, we hacked on PureCDN for about 8 months. We never took any VC or anything like that, and we didn't really know how to run a business. And all I knew really was that using WebRTC in this way was exciting, and I wanted to work on it because I thought few others were thinking about it, like this. So like I said, I mentioned the idea for WebTorrent as an afterthought with one slide. This was the slide. I typed it up in a few minutes before going on stage. It's actually funny because I still prepare my talks that way. But anyway, this was the slide, and the core pitch is basically the same. So it's BitTorrent in your browser, no plugins, and streaming playback, and that really hasn't changed very much. We never were really able to get the DHT over WebRTC to work, and it's kind of unfortunate because that means that WebTorrent never really became fully serverless or trackerless. But there's a lot of difficulties in getting DHTs to work over WebRTC, which is a whole nother talk. But anyway, so like I said, when I mentioned this, I was very clear this was just a crazy idea that I just thought of, and that I basically was very clear about this. It did not exist yet, and I wanted to build it, and I wanted interested folks to come up to me and talk to me about it. But some people didn't get that message. And so this was actually the first tweet announcing WebTorrent. And so this guy, R.L. Balkin, who's a tech privacy advocate and designer, basically tweeted it out to his pretty considerable Twitter following, who were pretty super excited to hear about it. The only problem was this is what the repo looked like. And I didn't cut anything out of this screenshot. That's actually it. That's the entire thing. I'll zoom into the code part for you so you can see. So a few hours later, he messaged me in surprise. He was like, oh, this is all you have? It's a README? Like, I tweeted this out to everybody. I thought you had code. And I was like, it is right there. You could look at it before you tweeted it. So I felt a bit bad, but so I quickly added a little note to the README saying, like, this project does not exist yet. But in the end, I think I would say I'm pretty grateful that he shared it, because even before it was ready, the positive encouragement from people who thought the idea was cool and who wanted to find out how they could help, or what the plan was for it, encouraged me to actually build it. And I actually think I likely wouldn't have built it or persisted through it if I didn't get that initial bump. So the lesson from that, I think, is to share your work early and often. And so I think basically momentum, right? Momentum is this incredibly valuable resource that people underestimate, and having people expecting you to release something or looking forward to what you're going to do next is a really great motivator for getting things off the ground. So yeah, I mean, and once you get a project going as well, this is also true, because you want regular wins to celebrate on a regular basis, and that's key to keeping contributors coming back, and even including me, keeping me engaged. So yeah, I think celebrating these milestones are good. Yeah, so I don't know why this slide is black. Oh, right. It's, yeah, OK. So this is a little timeline of just sort of the order that things happened in. So, so WebTorrent was announced in late 2013 by Earl. The company I was working on was acquired shortly thereafter, and then I took this job at Yahoo. And so basically, the story is Yahoo offered to buy this company, and they wanted us to add peer-to-peer video to their website, to the video player. And it's one of the biggest sites in the world, so it seemed pretty exciting. We were like, hell yeah, let's do it. Turned out in the end, they had a lot of problems being Yahoo, and we had to fix all those first before we could get around to peer-to-peer video delivery. That was the least of their issues. So anyway. While I was there, I released a BitTorrent CLI, which is sort of like the MVP of what WebTorrent was going to do in the end. And finally, at the end of 2014, there was actually something that worked in the browser end-to-end. Actually, this is a funny story. The night that this was actually finished was a night that I was in New Zealand, and I was in this really nasty hostel. It was like probably $12 a night or something, and it actually had bed bugs. And so I left the room and refused to go to sleep there, and I just sat out in the lobby and I just worked all night, and that was actually what caused this to actually get finished. So I was actually grateful in the end, but anyway, yeah, it was a bad hostel. Anyway, and so then I quit my job at the end of the year, and one of the things that's interesting here is I was working on WebTorrent throughout, so I think that's pretty cool. And then finally, I would say in the middle of 2015, it was actually pretty stable and useful. So the lesson from this for me was basically find a job that allows you to work on side projects, or at least find one that is sufficiently steeped in chaos that they don't know that you're working on an open source side project. Yeah. So then to continue the timeline, in 2016, we released a desktop app, which I'll talk a little bit more about later. Brave ended up adding WebTorrent to their browser. 2017. The end of 2017, I got a little bit burned out, which I'll talk about more in a bit. And in the beginning of last year, WebTorrent Desktop hit 1 million downloads, which is a pretty cool milestone. Yeah. So so basically, because of the whole little burnout thing, at the end of 2018, basically, I decided to take a little bit of rest and go back to university and get my master's degree. So I'm currently studying computer security, networks, and cryptography, which is pretty cool. It's the most fun I've actually had in a really long time. I'm learning how to formally prove that crypto systems are secure, what it actually means for a crypto system to be secure, how to define security. And I'm actually struggling quite a bit with some stuff, which is cool because it means I'm actually learning. So yeah, anyway, I'm getting a chance to learn about a lot of concepts that I've always wanted to understand, like homomorphic encryption and private information retrieval and stuff like that. Elliptic curves, lattices, all this kind of crazy stuff that I basically had no understanding of before. So I'll just say, if you ever get the chance to go and continue a formal education after you've been in the real world, it's actually really great. I highly recommend it. And so for this reason, I've actually been working on WebTorrent a lot less, and it's given me a chance to reflect. So hopefully we can learn some things. So quick obligatory stats page. The numbers, the latest numbers on WebTorrent. Probably the most interesting thing is that the JS library is included on websites, and it gets loaded 5 million times per month, which is pretty crazy. But yeah, the point of this talk isn't to share status updates. It's just I'm trying to make the point that WebTorrent has a meaningful number of users, so hopefully some of the learnings can be applicable. OK, so with the backstory out of the way, I want to discuss this paper, which I think is great. It's called The Rise of Worse is Better. I don't know if you call it a paper. It's more like an article, I guess. It's pretty short. Written by Richard P. Gabriel. He's one of the designers of Common Lisp. And he wrote this in 1989. And it was an extremely influential piece of writing for me. So I'll try to summarize it. Basically, the idea is he says that there's these two competing design philosophies in software. So the one is what he calls the MIT Stanford philosophy, which is basically this idea that, well, there's 4 things, right? So we'll just go through them. So simplicity, the design must be simple, both in implementation and interface. And the key idea is it's more important to have a really simple interface than it is to have a simple implementation. So it's sort of like take on the burden of making this simple for your users, even if the implementation is complicated. And then correctness, so the design must be correct. Incorrectness is not allowed. Consistency, the design must not be inconsistent. If you have to make the design less simple or less complete, you do that because you really don't want to have inconsistency. And then finally, completeness. The design has to cover as much as possible. All reasonably expected cases must be covered. So yeah, basically the idea is do the right thing. That's another way of summarizing it. Just do the right thing, make it good. This is the other philosophy, worse is better. He also calls it the New Jersey style, which is pretty funny. Yeah, so I'll highlight the parts that are different because a lot of it is actually repeated. So the key differences are the implementation has to be simple instead of the interface. So simplicity is the most important consideration in a design. So how do we implement this as easily as we can, as simply as we can? And then if you have to make trade-offs, basically you sacrifice everything else in order to make the implementation simple. That's kind of the key idea. It has some information about what you should trade off first, like slightly better to be simple than it is to be correct, and so on. But the key idea is simple implementation. So here's an example to make it concrete. So this is some C code that opens a file and writes to it. But it has a bug. Can anybody see the bug? Yeah, what is it? Wait, what? What did I do? Wait, what's this? Oh, OK. No, there's another bug. I don't check it. Yeah, I mean, so OK, ignore error checking for a minute. Yeah, that's a. There's another issue. What is it? Oh, I forgot to change the number. Yeah, OK. All right, ignore it. I had a different string in there before. OK. OK, what's the other issue?
Are you trying to do a logical OR there?
No, it's supposed to be a bitwise OR. Yeah. OK, I'll just say it since it doesn't seem like many people here write C. No. I think that's fine, right? OK. Anyway, the issue is that one of the issues, the point I was trying to make was that write might not succeed. Write might not fully write this string out to the file descriptor. So this is the correct code. So basically the idea is when you call write might return you a number of bytes that is less than the total number of bytes that you wanted it to write. This is because maybe the kernel got an interrupt and had to go do something else, and it didn't have time to write this all out, right? Or maybe the script you're writing to is blocked, or something like this, right? So your job as the user is you have to literally, every time you call write, you have to be like, maybe it's not going to actually write the whole thing that I just asked it to write. And you have to check, and then you have to do this math. Or I guess, oh god, there's another bug. I didn't do plus bytes written. Yeah, OK, so it's error prone. You basically need to offset into the buffer based on how many bytes you wrote. So there's a lot of anyway. The point is that this is classic worse is better design. So here we see that the simplicity of the implementation was favored over the simplicity of the interface. And now basically every programmer that comes along from now until we're not writing C anymore has to deal with this, right? But this is a type of pragmatism, and you can find this all over Unix and in C and in the design of the web. And this works. So Gabriel basically he says that basically the Unix solution was right because the design philosophy of Unix was simplicity, and that the right thing was too complex. Besides, programmers could easily insert this extra test and loop. And so then the MIT guy says, points out that this implementation was simple, but the interface and the functionality was complex, and that the right trade-off was selected in Unix. Namely, implementation simplicity was more important than interface simplicity. So this worse approach actually helped C gain adoption because it was easy to implement. It was easy to write a decent compiler for it. It would require the programmer to write text that was easy for the computer to interpret, for the compiler to interpret. So both early Unix and C compilers had simple structures. They were easy to port, and they required few machine resources to run, and it provided about 50 to 80% of what you wanted from an operating system and a programming language. That's the idea. What was that? 50 to 80, yeah. He's a Lisp guy, so he's a little bitter, I think, about C. Anyway, OK, so the way this applies to WebTorrent is, if you look at WebRTC, that's classic worse is better, right? Some might even say WebRTC is worse. But basically, it has performance issues, has a terrible API, yet it enabled peer-to-peer on today's web. And it proved that the DWEB is a valid web use case that web spec people should think about. And it makes it easier to argue for better peer-to-peer web APIs. So it's better that this was released with a bad interface than not at all, at least in my opinion. We have lots of real-world learnings now that we can use to shape what comes next to be better. And because WebTorrent is one of the users of this, we can actually have a seat at the table in helping the next generation that comes after WebRTC to shape the way it's developed. So yeah, lesson 3, worse is better. And then this is one more time restating it, I guess. The lesson to be learned from this is that it is often undesirable to go for the right thing first. It is better to get half of the right thing available so that it spreads like a virus. Once people are hooked on it, take the time to improve it to be 90% of the right thing. Yeah, that's the idea. So one of the ways that WebTorrent embodied this worse is better philosophy is the way that we implemented the most minimally useful thing that we could think of, which was a BitTorrent app that worked on the CLI. So the idea was, like, eventually this is going to run on the web, but first we have to implement a BitTorrent client, and then we can add the web stuff. So we designed it from the start with a plan to eventually make it work on the web, but we didn't worry about getting all the technical decisions exactly right beforehand. The goal was to get something working like reasonably quickly without an insurmountable amount of tech debt, and with a willingness to tolerate some grossness in the implementation, but the goal is to ship something useful to real users quickly. So, to emphasize, worse is better doesn't mean that you intentionally write garbage code. It just means that you focus on providing value sooner rather than later, and you initially ship something to users that probably falls short of your full vision, and you do this intentionally, right? This is actually okay. This is the idea. So, lesson 4, provide value along the way. So pictorially, this is what it looks like. You want to be the red line, not the blue line. You want to provide some modicum of useful functionality at every point in time in order to survive. So one of the ways that we provided value along the way was to focus on a single concrete use case. This is after we already had the BitTorrent CLI working. So we wanted to make some subset of our users perfectly happy. For WebTorrent, that meant focusing on the use case of displaying a torrent in a web browser. So the relentless focus on this single use case helped us develop pretty clear messaging, torrents on the web. And eventually, we redesigned our homepage to focus all around this. And you go to the page, and you can literally see it in action immediately when you land on the site. And it emphasizes that the whole point of WebTorrent is to reduce the friction of using peer-to-peer technology, to make it transparent, so you can't even tell this is peer-to-peer, except for the peer-to-peer graph next to it. But the video, we added that. You don't have to add that to your site. And it makes it possible for non-nerds to use the technology. That was the point. So I think that this messaging was effective. So anyway, one of the best things we ever did was to have a simple code example at the top of the documentation. This is also added to this. It showed users that there's this magic functionality is possible, and it got them sort of itching to try it for themselves. So for this rule, I actually think that we embodied more of the MIT Stanford design philosophy. So instead of worse is better, because we actually started with this code example and said, I want to make the API work like this. This is what I want the users to be able to do to make this use case as easy as possible. And even though this resulted actually in quite an extremely complicated implementation, specifically for this method, because this is crazy. To be able to take an arbitrary video file and be able to stream it into a video tag is a nightmare, right? It's really hard. All the formats, all the complexities of buffering the pieces and when the user seeks and all this stuff, it's crazy. So most of there's an insane amount of complexity in that one method, but in this case, we decided it was worth it, right? If you want this work, by the way, you can just do that and you can use it. Yeah, so lesson 5, solve one use case perfectly. So ask, who's your ideal user? Can you solve their problem completely? Can you turn them into a huge fan? Can you design an API that wows them and makes them into an instant fan? if you can do this, then at least for WebTorrent, it made us, I think, a lot better off than if we tried to do like a lot of different things in a more mediocre way, at least in our experience. This leads me to this idea that technical bets are multiplicative. So WebTorrent had tech risk from a few different things. Like for example, maybe JavaScript is going to be not around in 5 years. Probably not, but maybe ES6 could have screwed everything up or something. Who knows? Then we also chose to use Electron for the desktop app. We were one of the first apps. There's some risk associated with that. And then we also made a bet on WebRTC data channels. That was probably the biggest risk. And so if you plug in real numbers for like how likely do you think it is that the bet on that technology is likely to succeed, you quickly see that WebTorrent only had a 38% chance of success. Maybe that's pretty high. Who knows? Maybe the numbers are completely wrong. But the point is that thinking in terms of technical bets in this way is useful, I think. Because if we had decided to add additional technical bets, then we would have basically had a lot less of a chance of succeeding, I think. So the flip side to this is some projects are more ambitious than WebTorrent, and they actually might require more technical bets than the ones we had to make. There's maybe no way around this. But in the case of WebTorrent, we benefited by reducing the number of bets to the absolute minimum. So for instance, like we didn't redesign the protocol. We just used BitTorrent, basically, which eliminated a whole bunch of potential problems. So technical bets are multiplicative. Be very careful about the bets that you take. So when we introduced the desktop app, which I'll talk about in a bit, we faced the problem of how to describe the desktop app in relation to the WebTorrent library in an understandable way. So why are there these two things, right? Like, which should the user use? And eventually, we just boiled down the pitch to two things: torrents on the web and torrents on the desktop. And users who wanted a standard torrent app could just show up and select the desktop app. And then more adventurous users, they could explore the library and look into that aspect of the project. So lesson 7, have a simple pitch. The pitch for why someone would want to use WebTorrent was pretty clear. And like we insisted on having a simple pitch. We tried to show rather than tell. And if a user, I'd say if a user comes to your site and they can't figure out what your project does by looking at the part of the website that shows up above the fold, the pitch may be too complicated. So on the other hand, like maybe we're a little lucky in the sense that torrents are pretty well understood technology, like relatively speaking. So they've been around for a while. So we had a little bit less explaining to do. But even so, we kept simplifying the pitch until we ended up with a pretty simple pitch, which I think is as simple as it could get. But even with our simple API, I think I would consider it if you can simplify even further. So this code snippet's actually from a project that Michael Rogers created, which was a way to basically use WebTorrent with custom elements. And it didn't require users to know JavaScript. And I think it's pretty game-changing. Like we really should have integrated this into the core library, but we haven't done that. And that's really, I don't know why we haven't done it. But basically, it's a total no-brainer because you can basically eliminate the need to know JavaScript, and it helps users who aren't super comfortable with necessarily like all the complexity of setting up a build tool chain in JS land to be able to maybe someone who can just edit a website's HTML. They're a developer in another language, and they can now suddenly use it. So yeah, this would have been I think a really good idea to have added. I think maybe the evidence for that is like if you look at who's using WebTorrent and how they're using it, oftentimes they're not using it directly. They're not using the JS API. They're actually using some other integration or some wrapper around it. So even the simple API is still actually too hard. So this actually is why we built a desktop app, even though it's counterintuitive at first, because we wanted to offer some sort of value for users who weren't ready to adopt the full vision of WebTorrent. Users who just showed up and said, give me torrents fast. I don't care. Like, I don't care about your story. I just want torrents. And then maybe eventually they could learn about the whole vision, right? That was the idea. So lesson 8, design for the least technical users. So I think if we had done I think we did an okay job, but if we had done a better job of doing this, then we would have been forced to question like basic decisions that ended up raising the barrier to adoption, like the fact that you needed to understand JavaScript in order to use the API. Do we really need to force users to know JavaScript to use WebTorrent on their website? No. So I think part of that was our love of JavaScript and our experience with it made us a little bit blind to that. But yeah, this advice is actually pretty hard to follow. We struggled to follow it quite a bit, I would say. I mean, part of the issue here is that GitHub issues are opened by people who have GitHub accounts. So those are not normal users. They're, unless you go out of your way to seek feedback from normal people, you're going to end up sort of over-prioritizing the concerns of people who are nerds, basically. I use the term nerd affectionately because I'm a nerd too. But yeah, so for WebTorrent, like prioritizing the nerd concerns was the default, and we had to actually try pretty hard to like not do this. The nerdiest users are going to demand a lot of attention on features that are not going to help the normal user, and those are the majority of the users, right? And also, the types of features that they often want are complex and actually can suck up all of your time, not just to implement it, but to sort of maintain it in the long term as well. So we created this GitHub issue template to sort of kindly tell them no, and we use it a lot. So one time when we didn't do a good job of this was when we got this issue on the desktop app. Basically, in response to the outcry of a few users, the problem was WebTorrent was setting itself as the default torrent app without like asking the user, which is not good. But hey, it was like a initial app, initial decision, like whatever. So anyway, someone made an issue saying, hey, you shouldn't do that, which is true. And they sent a PR to fix this, and there was a bit of like sort of a outcry on the comments, like you should merge this right away. So we merged it and didn't really review it that well, as well as we should have. And there was this bug where it basically stopped setting it as the default for all people, even if they didn't have any other torrent app on their computer, which led to this really bad situation where a normal user who has never torrented before downloads the app, goes and clicks on a torrent file, and then it says you don't have an app installed, that can open this, and they're like really confused, right? Because now they have to go into the preferences and say set as default. It's just bad, right? And to this day, this actually confuses new users, and I don't know. It's gotten a little better, but the issue the edge case is still there, and it's actually affected the growth of the app, which is not good. So if I could do it all over again, I would have told this person to go away, and I would not have merged this, or I would have done it in a more thorough way. So basically, I think we should have listened to the criticism, but we shouldn't have necessarily, just jumped on it, and I think things would have been fine. Okay. Another issue, so telemetry. This is a kind of a controversial one in the open source world. So telemetry means sending basic stats about an app's installation, and maybe some additional things like uncaught exceptions, and sending a little bit of info whenever the app checks for updates. And so we actually do this in the desktop app, and we visualize the info on a dashboard that looks like this, and committers have access to this. And this decision actually was great. Like this single decision helped us fix so many bugs in the app. I can't emphasize this enough. Basically, the core library, the core WebTorrent library, has no telemetry, right? It doesn't make sense, in my opinion, for there to be telemetry in the core library. But because of this, there's all these uncaught exceptions that we just didn't know about because users didn't report them, or maybe they only happened 5% of the time. And so it just led to sort of certain peer connections disconnecting. And so the overall efficiency was less, but we didn't know about it. And so, users run into errors all the time and they don't report them. And the errors might not crash the whole library, so they might not even know that there were errors. They might be silent. And this can reduce performance, and, the fear here is if you add something like this, you're going to get this pushback from privacy purists or people who I don't know, are unhappy about this for some reason. And I think that I have no regrets about this. Basically, the good outweighed the bad really by a lot. And you can see actually with each of these green lines here, each of these is a release of the app, and you can see how this is our error rate. Just once we had this graph, we just sort of pushed the error rate way down, which is what the whole point was, right? This is actually crazy. This means 10% of the users got an error, even when we got it down. 10% of users had an error once every 12 hours, which is still really high. Not all of them are fatal, but anyway, you can see the progress is good. We also have access to these stack traces, and we scrub the error messages using a regular expression to prevent any information about specific torrents from ending up in a stack trace. It's only failed a couple times, and then when that happened, we improved the regular expression, and now it never fails. And then the generic information that we send, like the operating system that the user's on and what version of the app they're using, is super valuable to let us know that our auto updater is working. And this is actually really cool. This is what an auto updater will do to your versions. Basically, as soon as you see a version come out, the vertical line, you get this plummeting of that version and then the rising of the next version in usage, which is exactly what you want to see. So we didn't know that it was working until we saw this. So yeah, I think basically the lesson here is ignore the nerds. Like, listening to the nerds made WebTorrent worse for non-nerd users, which are the majority. So the thing about this is, like, startups that are creating consumer apps are hyper-focused on their user numbers and on this kind of this telemetry stuff and how to get those numbers up. And in many ways, they're actually focused on this to a really unhealthy degree, leading to all kinds of dark patterns and nasty growth hacks, and that's perverse, and we don't want to do that in our apps or in any. I don't think the DWEB app in general wants to do this kind of stuff. But many of these DWEB projects make little or no effort to actually grow their user base, and then you'll see people complaining on Twitter about how everyone is using centralized corporate platforms, right? And they're complaining on Twitter. So, like, generally speaking, I think like tracking this stuff is actually really valuable, and if more users download your app, that is a good thing, and you should want that, and you should try to actually track that. It's not evil or wrong to care about that, and if you think your work helps people, then you should want to get it into the hands of more people. At least that's how we thought about it. And to us, like the first step of this was knowing how many users we actually have, and how that number is changing over time. So anyway, we took the most minimal approach as we could. Like you see here, this is basically all the info we gather. It's not very much, and this just gets sent anytime the app checks for an update. And all this stuff helped us make the app better. We only added it if it actually helped answer some question that we actually had. And then then we made these charts, which are really motivating. Like you can see here, like this was actually when the server, the update server ran out of disk space and stopped tracking downloads. But other than that blip, yeah, you can see all the other blips have some significance, and that was actually really motivating. And we were also able to see when we broke something that users actually stopped using the app. So this is a retention graph, and you can see here, this is basically how many users opened the app up in the last 28-day period. Yeah, so basically lesson 10, growth matters. When WebTorrent actually added telemetry to the desktop app, our user growth, it didn't take over our lives. We didn't become obsessed with it. We didn't turn evil. We didn't start using growth hacks to make the numbers better. We just knew that it was there, and it gave us some much needed feedback about crashes, and it was really valuable to making the app better for real users. So the flip side of focusing on big picture goals like getting our software into the hands of more users or adding new features is actually responding to issues. So some of the most difficult times motivationally for me was when I was overwhelmed with issues and I ended up in a reactive mode instead of a proactive mode, and I forgot about the higher level goals of the project, and I was basically just sitting there fixing bug after bug after bug that were filed by random people. And this is generally good, but it's a ticket to instant burnout if you do this 100 times in a row. Like chasing down these random rare issues that only affect some random person on like a Linux variant that no one uses, like Gentoo or I don't know, whatever, it kills the joy, basically. So yeah, I think basically it's a huge time suck, and a whole month can go by where you're really working really hard, but then you have no visible progress. And this is probably the main reason why I experienced a little bit of this burnout in the end of 2017. So lesson 11, be proactive, not reactive, at least for me, personally. Focusing on what's most important to the project is the way to go. And if you focus on being reactive instead, then it's difficult to stay motivated in the long term. Okay, and this is going a little long. I only have I think 2 more lessons, yeah. So one of the things that can help a project stay proactive instead of reactive is having a roadmap and having regular meetings where you discuss progress toward that roadmap. So I have no advice about actually how to do this because we did not do this. We had no regular meetings of contributors, not on IRC, not on video, not in person. Like sometimes I'd meet a contributor at a conference and we'd talk or hack for a little bit. but there was nothing regularly scheduled, like actually zero. Zero things were coordinated. So I think that this is probably because I personally have a really strong aversion to organization and hierarchy, and I felt uncomfortable like making a meeting to do this, which is in hindsight kind of silly. And I think it's actually incredible that contributors were able to show up and actually make useful PRs to the project and figure out what to do. And we actually were kind of all going in the same direction somehow. But meetings would have probably helped me learn like what contributors were looking for in the project and retain them better and figure out like mentor them, see what they need, help them, just contribute better. And we could have had some kind of a I don't know, it wouldn't have been that hard. I think there are projects who do this well. Like people, this may be obvious to some of the people here. Like I think IPFS and DAT are good examples of how to do this well. So maybe this is kind of obvious, but we never did it. And if I could go back, I would do this differently. So building decentralized software with centralized coordination is okay. Not all centralization is bad. Okay, who here has heard of the phrase mechanical sympathy? Okay, 2 people, 3 people, 4 people. Okay, the term mechanical sympathy was coined by this race driver named Jackie Stewart, and then it was applied to software by Martin Thompson. So Jackie Stewart said basically, you don't have to be an engineer to be a racing driver, but you do have to have mechanical sympathy. So basically what this means is you need to understand how the car works. Understanding how the car works makes you a better driver. You don't have to be able to build the car, but if you know how it works, you're going to be a better driver. So I think this is obviously true for writing code. If you don't have to be a chip designer, but if you know like what operations are faster than other operations, you're going to write more performant software, and you can take that into consideration while you're coding. But one thing that's kind of interesting is when developers use software, I notice that they have a lot of mechanical sympathy, like just as users of the software. Like they will avoid stressing the software in a way that is likely to break it. So like we kind of know like if I check this box and then I like go back and then I go back and I uncheck it, like probably going to be some kind of a state bug, maybe. Like the sad fact is like anything that diverges from the happy path, like the default way of going through the app, might cause issues. So you as developers will use an app and sort of avoid the little potential edge cases that will trigger a state bug. But normal users, on the other hand, they don't care. They will push all the things, right? They'll add 100 torrents to WebTorrent all at once, turn them all on, and then they'll say, "Why is my app frozen?" Right? And like I would never do that, and no other developer who works on the project would do that. Like I'll add one at a time, wait for it to download, and then I remove it because I'm bad. I don't seed. Okay, but but one at a time because I don't want to stress the software, right? But this is really bad. Like we should do a better job in the case where the user adds 100 torrents. Like this is how people actually use real software, right? This is someone's desktop. This is what people do. So basically I think that the sad truth is a lot of DWEB apps are just not fast or reliable, WebTorrent included. And this is oftentimes at a low level too. Like it's the actual protocol and its implementation are just flaky, right? And this leads to a flakiness that reverberates upward through the stack at every level. And this is like, I think it's network engineering is hard. And if you're reinventing stuff, it's going to be doubly hard, especially in a peer-to-peer model. Like it's harder to debug peer-to-peer applications than client-server applications. So for whatever the reason, like we somehow lack the tooling or the expertise or the resources to make things fast and robust. I don't know. It makes me sad. I think we can do better. We have to do better. So lesson 13, DWEB apps are not robust yet. I think this is ironic because I think they have the potential to be more robust than centralized applications because they often can support offline a lot easier, and like local caching is a lot more natural. But currently, we fall short. And I think when we finally get this right, like it's going to be so much better than centralized applications. So this is maybe an optimistic point. Like once we get this right, it's going to be so good. But right now, most apps and protocols just still feel very alpha quality in my experience. And basic things just fail a little bit too often. Getting something working, I guess, is like the first 80% of the work, and then the next 80% of the work is to make it robust. So, anyway, on a more positive note, I just want to, I guess, conclude with saying that I think conferences like this are, I don't know, they're inspiring, and they're one of the reasons why I'm interested in peer-to-peer still after all this time, and I feel really grateful to be part of the community here and to have, to talk to all the different individuals here about stuff, and the fact that we've collaborated on different things over the years is really, really cool. So yeah, the opportunity we have with this DWEB stuff is huge, and it feels like many of our efforts are like right there on the cusp of being like realized, but we just have to do that last push over the edge and make things like really robust and really good. So I can't wait to hear the rest, hear more from the rest of the talks today and tomorrow, and looking forward to chatting with you all. So the opportunity is huge. Happy hacking.